So in this video, we're going to look at the third question in vertical motion under gravity. So a particle is projected vertically upwards from a point O with speed u meters per second. So here's our particle that's being projected upwards with speed u meters per second. This is the point O, and because it's being projected upwards, we'll treat our positive direction as straight up the page. So this will be our positive direction going upwards. So a negative in any of this means that it's going in the opposite direction to that, so it'll be going downwards instead. So here's our particle being projected upwards from a point O with speed u meters per second. The greatest height reached by the particle is 62.5 meters above O. So as the particle goes up, eventually it's going to get to its top bit, and that distance there, that distance is 62.5 meters. And obviously at that top point, when it gets to there, this reaches maximum height. Remember, gravity is working down the page. It's working against gravity, so our acceleration will be downwards. So it's accelerating this way. So because the positive direction is upwards, the acceleration will be downwards 9.8. That's meters per second squared. When the particle is initially released, it's going upwards with the speed, but gravity is working against it. Eventually it's going to get to the top, and at the top, remember, its speed will be 0 meters per second, because there's that instant where it stops going upwards, and then it's going to start going downwards. Its velocity is going to become negative. Find the value of u. So in this question, we don't have u. We've got v, which is 0, based on the 62.5 that we've got here. If we talk about that displacement from the point O, 62.5 meters is going to be s. And the acceleration is here, minus 9.8. It's against the direction of travel. Meters per second squared. So we've got u, v, s, and a. So this time I've written out our SUVAT formula. So we're looking for u, we've got v, and a and s. So it's going to be this one here, this third one down that we're going to be using. So v squared is u squared plus 2as. V is 0. U we don't know. A is minus 9.8 and s is 62.5. Simplify this and we'll get u squared minus 1225. Rearrange. And so u will be 35 meters per second. Okay, so let's have a little part B. Just to highlight on part A, obviously when we square root our 1225, we could get negative 35 as well, which would just mean that the particle is traveling downwards instead, and that's what would happen if we take 62.5 meters. So we can kind of ignore that because we know that the particle is traveling upwards in the positive direction. This one. Let's have a little look at the second part. So part B. Get the ruler out the way. So part B. So part B says the total time for which the particle is 50 meters or more above O. So here's our particle. It's going to reach 62.5 meters. We want to find how far it is above 50 meters above O for. Okay, so we know that it would reach 62.5 in total. And we want to know for how long it's 50 meters above O. So we're looking at the displacement being 50 meters from O. So if we think about what's going to happen, the particle is going to travel upwards. At some stage, it's going to get to the point where it is 50 meters above O. It's then going to go a little bit higher because we know that it gets to 62.5 meters above O. We're told that in the question. It's here as well. And then it's going to stop and it's going to start coming back down. And then again, on its way, so it goes up here, up to there, comes back down, and then again at some stage it's going to be 50 meters back above O again. So if I'm looking at this question, I'm looking at where S is 50 meters. If I can work out the time where it's 50 meters displaced from O, then there should be two instances of that. There's the instant where I'll get a time for when it's on the way up, which is this, where it's here. It goes past that point up to 62.5, and it comes back down, and I'm going to get a second time for when it's passing back downwards, and it goes back through that point, which is 50 meters above O. So if I consider S as 50, I should be able to work out both those times. Okay, we've now got U. So we don't have T, we now have U, which is 35 meters per second from part 1. And we still have our acceleration due to gravity, which is minus 9.8. Because it's going against the positive direction. Remember, the positive direction is here, it's up the page. So the equation I'm going to be looking at, I've got S, T, U, and A, which is this equation here that I'm going to be using. Okay, and you'll notice if I don't know T, this will be a quadratic in T. So I'm potentially going to get 2 times for T, which is good because that's the one. One time will be where it's going up. As it gets 50 meters away from O, it goes past that up to 62.5, and the other T that I'm going to get will be where it goes down back 50 meters above O, and then obviously it's going to continue down past O again and go down towards the floor. So let's sub in. So S equals UT plus a half AT squared. So we want a displacement of 50 from O. U is 35, we don't know T. Plus a half A, which is minus 9.8, and then we don't know T again, so T squared here. Just tidy things up a little bit. 50 equals 35T minus 4.9 T squared. Again, quadratic in T, we've got a T squared term here, a T term here, and a constant. So let's get one side 0, and then again, because it's a bit of an ugly equation, so add 4.9 T squared minus 35T, 50 will stay where it is. I'd probably just go straight in and use quad formula on this. So T will be minus B, so minus 35 is plus 35, plus or minus the square root of B squared minus 4AC. Just extend that all over 2 lots of A. So if you simplify the bit underneath the square root, you get 35 plus or minus root 245 over 9.8. So we can get 2 values of T, which is what we expected and what we wanted, because there'll be 2 different times where it is 50 meters from O, the time where it's going up and the time where it's going down. So let's work both of them out separately. So T will be 5.168-ish, or T will be 1.974-ish. So this represents, if I just go on this side again, just to go through it again. Here's a particle at O, it's traveling upwards, it gets 50 meters above O after a certain time. Obviously that's going to be the first time, that's going to be this one. So that's where it's at this point here. It's going to carry on up until it's 62.5, the total maximum distance from O. Then it's going to start coming back down again, and when it passes through T the second time, so as it's on its, so it stops here, on its way back downwards now, it goes past that 50 meter point again. That's going to be this second time is where it's passing back down through there. So the time where it's above 50 meters is the difference between these 2 values for T. So therefore, our time spent over 50 meters is going to be 5.168. That's when it's returning back down, minus 1.974, which is when it initially went 50 meters, past 50 meters above, and you get 3.194. Sorry, it's got a little bit messy. 3.19 seconds to 3SF.